In this section, we're going to look at a few problems that can be solved by factoring and kind of review how that works. Remember, solving by factoring, once you have everything factored, you just set all your factors equal to 0. And that's it. So let's start kind of simple. What if we had x cubed minus 5x squared equals 0? Okay, well, we'd factor it. Start off by looking for your greatest common factor, GCF. Well, that would be x squared. That gives me x squared times x minus 5 equals 0. This is really x times x minus 5 equals 0. We're going to set our factors equal to 0. Well, over here, when I set x equal to 0, I just get x equals 0. I actually get it twice. It's kind of a double solution. Here, when I set x minus 5 equal to 0, I'm just going to get x equals 5. And we're done. But now let's look at it a little bit harder. 2. What if I had x to the 6th minus 4x to the 4th minus 9x squared plus 36 equals 0? All right, our first step is to look for a greatest common factor. There's nothing in common. Nothing. Well, there's 4 terms. I wonder if it'll factor by grouping. Now, you're welcome to do the factoring by grouping with the traditional method or using the factor box. With the factor box, the multiplication box, you would put each of your terms in there. So x to the 6th, and this would be negative 4x to the 4th, negative 9x squared, and 36, positive 36. And we look for what they have in common. Between x to the 6th and negative 4x to the 4th, we have x to the 4th. X to the 4th times x squared gives me x to the 6th. X to the 4th times negative 4 gives me negative 4x to the 4th. X squared times negative 9 gives me negative 9x squared. And negative 9 times negative 4 gives me 36. Now, these are my factors. I'm also going to show this to you with the traditional method. These two, what do they have in common? They have x to the 4th. When I factor that out of both of those terms, I'm going to get x squared minus 4. These two, I'm going to actually factor out the negative 9. When I do that, negative 9 times x squared gives me negative 9x squared, and negative 9 times negative 4 gives me 36. Both of these have an x squared minus 4. If I factor that out from each term, I would get x squared minus 4, and in the next parentheses, it would be x to the 4th minus 9. Look at the factors we got by using the factor box. X to the 4th minus 9 and x squared minus 4. We got exactly the same thing. Now, we see if we can factor any more. X squared minus 4. Yep, that sure does. That is the difference of 2 squares. So I'm going to get x plus 2 and x minus 2. Over here, we have the difference of 2 squares. So I'm going to get x squared plus 3 and x squared minus 3. Now, check to see if I have any more difference of squares. I don't. So I'm going to set each factor equal to 0. These are easy. For x plus 2, I'm going to get the solution x equals negative 2. X minus 2, I get x equals 2. But these two, I'm going to actually have to see what happens. If I set x squared plus 3 equal to 0 and solve it, I'm going to subtract 3, so I get x squared equals negative 3. Square root of both sides, I get x equals, don't forget your plus or minus, the square root of negative 3, which is imaginary, but that's okay. It is a solution. I get the square root of 3i. If I take the next parentheses, x squared minus 3 equal to 0. Add 3, x squared equals 3. X equals plus or minus the square root of 3. So I have these two solutions, positive and negative, these two, and these two. I actually have 6 solutions in all. Let's look at another one. Number 3. Okay, I was having to make one up really fast. This one's going to be x to the 5th plus 9x cubed plus 8x squared plus 72. Now we can do it either way. You can use the box if you want. I'm going to kind of do it the old-fashioned way and look at what these two have in common. They have an x cubed. What's left is going to be an x squared plus 9. These two have an 8 in common. If I factor that out, I'm going to get an x squared plus 9. Each of these have an x squared plus 9. So it can come from both of them. X squared plus 9. And then I would have left the x cubed that's left here and the 8 that's left in the other term. This is not the difference of squares, so I can't do anything with that one. I'll just kind of rewrite it. But this next one is a sum of cubes. Sum of cubes. A cubed plus b cubed. It's going to factor into a plus b. So this is going to be x plus 2. The next term is going to have a squared, so it's x squared. Since this is a plus, this is going to have a minus. The 2 together, so 2x, plus the last one squared. So 2 squared is 4. This does not factor anymore. It is prime. So I can't really do anything more with it. So it's going to take a little bit of extra steps when we go to actually solve it. So I'm going to set each of my factors equal to 0 and solve. X squared plus 9 equals 0. Minus 9, I'm going to get x squared equals negative 9. It's going to be an imaginary answer, but we can still do it. Square root of both sides, I get x equals plus or minus the square root of negative 9, which would be x equals plus or minus 3i. X plus 2, well, that's an easy one. I'm just going to bring that down. That's going to be x equals negative 2. For this one, when I set it equal to 0, it will not solve by factoring. You have other ways, though. We can do completing the square. You can use quadratic formula. Whatever works for you, but it will not factor. I am actually going to use completing the square for this example because there is no leading coefficient, and this is a nice even number. To do completing the square, I would subtract 4 to the other side. then I would see how I could turn that into a perfect square. Well, it's going to be half of that middle term, so this is going to be x minus 1. What's missing is that middle term, or this number squared. So when I square negative 1, I get plus 1. I have to add that to both sides. Negative 4 plus 1 gives me a negative 3. Now, I can take the square root of both sides. X minus 1 equals plus or minus the square root of negative 3. X minus 1 equals plus or minus, that's the square root of 3i. It's an imaginary answer. So x equals, I'm going to add the 1, plus or minus square root of 3i. I would have been fine with using the quadratic formula as well. But however you do it, it will not factor. It's going to be a complex number. So you're going to have to be prepared to do a touch more work when you have the sum or difference of cubes.